Namaskar and welcome to my channel. Today we are going to discuss about a simple problem related to fluid dynamics, and the type of question is very simple. So in the question we have given a U-shaped tube of uniform cross-section area. So it is the identical tube, we can suppose, and it contains the water. Alright, it contains the water to a height h. Suppose the level of water is at h distance above from the ground. If the water on the one side is depressed, then what happens? You can easily think that if the water on this side is depressed, then obviously the water level will rise on the other side. If the one side is depressed a little and then released, then so that its up and down motion is simple harmonic. Obviously, if the water of one side is depressed a little, then the water level will rise on the other side, and if the depressing force is removed, then of course there will be the to and fro motion of the liquid inside the tube, and we have to show that this motion or this to and fro motion is simple harmonic. So to show the simple harmonic motion, we must have to show that the acceleration proportional to displacement. Negative sign indicates that the direction of the acceleration and the displacement is exactly in opposite. The direction of acceleration and displacement is in the opposite direction. So our goal is to find the acceleration. So let's try to find this out. Suppose this is the initial level of water, and let this point be A and this point is B. Suppose if I depress liquid in the left column, suppose I depress it through a distance y and it comes into A prime, right? Then the same amount of water level will rise in the right column. So here we have the two level. This is the depressed level, and the initial level. And this is the liquid rise in the right column. So this is also y, and you can see here, and this column of water really access the pressure, right? This column of water really access the pressure. The amount of access pressure now is given by access pressure equals S rho G, but here H is 2y. This liquid column creates the pressure, so H is 2y here and rho G. This is the access pressure. Of course, you can see here that this access pressure creates the restoring force on the left column, right? This access pressure creates the force restoring force on the left column. So the restoring force in this column is given by force equals axis pressure into cross-sectional area, because we know that force pressure equals force upon area, and to get the force we can multiply pressure and area. So force equals axis pressure into area. So we have the axis pressure is 2 y rho g times a, and here the sign is negative. The negative sign indicates that the displacement y, the direction of the displacement y is opposite to the restoring force, because the restoring force creates in the upward direction, but we have the displacement in downward direction, because we have the displacement in the downward direction, but we have the restoring force in the upward direction. So the direction is exactly opposite, so the negative sign comes here. This is the restoring force. And finally we have to find the acceleration. So we can see that this restoring force must be equal to mass of the liquid times accelerations. Alright, so restoring force equal mass into accelerations, and we have mass is volume into density, and volume is simply the 2h times cross-sectional area. This is volume and this is density, and this gives volume, and this is density, and volume times density gives us mass, and we have the acceleration A here. And also I have calculated the restoring force here. The restoring force is negative of 2y rho g and a. So simplifying these equations, we can get simply minus 2y rho g a equals 2 as a rho a. Alright, so these 2 and 2 cancels out, a cancels out, and anything here? Oh no. Okay, then acceleration equals minus g y, and rho also cancels out, gy upon h, or simply minus g upon h y, and g is constant, h is constant, so we can simply write a proportional to minus y. So here we have seen that acceleration is proportional to negative of the displacement, and so the to and fro motion of the liquid inside the tube is simple harmonic motion condition. Thus we can see that the to and fro motion of the liquid inside the tube is simple harmonic in nature, and the amount of acceleration is just minus gy upon s. Thanks for watching.